Okay, assalamualaikum everyone. Today, inshallah, we're going to continue with the second session of objects and classes. And we're going to state the difference between static and instance methods as well as static and instance variables. And we're going to see the referencing of objects in Java. So let's start with the first exercise, which is in practice assignment 8 and exercise 1, which is the point. So here we are asked to implement a Java class point and augment our class with a constructor that initializes a point with both its x and y coordinates in addition to the parameterless constructor. So let's first start with this. Okay, and here we have our class point, and we're going to define our instance variables, and any point is defined by its x and y coordinates, and they can be double, so we'll have our instance variables as double. So we have double x as well as double y. And then we want to augment our class with a parameterless constructor, so we say public point, no parameters, however you should write the brackets. And then we're going to put our default values for the x and the y, so we can say x is equal to 0 and y is equal to 0. Of course, it's automatically typecasted to 0.0. You don't need to write it. However, it's 0.0. Okay, and for the second constructor, we say public, and then point, and then we will give or we will pass our parameters, which are two parameters, which are the double x and double y, and then we will initialize our x with the x from the input and our y from the input. And to do this, as we said last time, we need to have the this keyword, and we say this dot x is equal to x and this dot y is equal to y. Okay, so far? It's like the first time, nothing extra. So let's continue. And then we are asked to augment our class with the following methods. And then you have the definition of the first method, which is static add point p1, point p2. And the definition says that it returns a new point as a result of the summation of 2 points p1, p2 in the x coordinates as well as the y coordinates. First of all, in this line, you have a new keyword here, which is static. And we need to understand the meaning of static. Static means that this method belongs to the whole class. It does not belong to an explicit or on one object, which means that something like the main method. The main method is static, if you remember. So the main method belongs to the whole class, and you do not invoke it on an object. Also, this static method, this add method is static, which means that as long as it belongs to the whole class, we will not invoke it on any object, which means we will invoke it by itself, and we will pass all the parameters, including the objects if we need, as an input to this method. Okay? Once more, if you want to add, and we add 2 points, you can see the definition of the method that it takes the 2 points as inputs. It does not take only one input point and the other one will be invoked on it. No, it takes the 2 points as input, which means that for static methods, all inputs should be written in the bracket, and this method will not be invoked on any object. So let's try to implement it. We say public, and then static, and then the return type. If you see from the definition, it returns a new point. New point. It does not return a double. It does not return an integer, for example. It returns a point, which means that the return type is point. So by this, we will return a new point, which is the same name as our class. We'll see how. And then we will call it, for example, add. And then comes the inputs. And from the definition, we pass 2 points as input. So we'll say point p1, comma, point p2. And then we'll write the body of our method. What we'd like to do is, we would like to return a new point as a result of the summation of 2 points p1 and p2 in the x as well as the y coordinates. So we can say something like this. We can say point P, for example, is equal to, in the definition he said a new point. New point, to create a new point, you need to add the keyword new. So we say new, and then point, and then we would like to give it the x and the y coordinates, which are the result of the addition of p1.x plus p2.x for the x coordinates, and p1.y plus p2.y for the y coordinates. So here we say p1.x, because p1 is an object. We want to get from it the x part. So we say p1.x plus p2.x, comma, and this is the x part, x coordinates, and then we say the same for the y. We say p1.y plus p2.y. And then if you remember, we need to return a point. You created the point, but you need to return it, so we say return your new point, which is the p. So we say return p. Okay? Or you can do it in only one line. Instead of these two lines, you can do it in only one line, and you can say return new point, and then we have the same values like this. And here we do it in only one line like this. Okay? Good. This is the static add method. We continue. We say here, another method is add, and it takes as input point P, and it adds the values of x and y coordinates of P to the point object on which the method is invoked. This line says that this method is an instance method. How did you know? Because here it says to the point object on which the method is invoked, which means that this method will be invoked on a point object. So this method is instance method. So what we can do is we'll write the same method for the add. However, we'll write the instance version of it. So we'll say public, we'll not say static, and then we'll say yeah, by the way, here it didn't say that we return a new point. It just said that we will add the x and y coordinates to your object, which means that addition does not return anything, then it's void. Okay? And it's called add, and it takes as an input only one point, that you can call it p. And then we would like to do what? We'd like to add the x coordinates of the p to my x coordinates. And we'd like to add the y coordinates of p to my y coordinates. So what I will do is, we can say this dot, and then x, this dot x, plus equal p dot x. And we say this dot y plus equal p dot y. And that's it. Okay? We can also remove the this from here, because if you just say x plus equal p dot x, it's already known that this x belongs to the object that you will invoke the method on, so you don't need to have this keyword here. But you need to state p dot x and p dot y. Okay? Okay. This is the static method, and this is the instance method. You will see the difference exactly also when we call both methods in the main method, as we'll see in a few seconds. Okay, another method we want to do is we want to swap point P1 and point P2, and it says it swaps the values of the x and y coordinates of both P1 and P2. And as you see that both points are given as input, and it is declared before that it's a static method, which means that this method will be called on its own. It will not be invoked on any object, and we will say something like swap P1 and P2. So let's define our method. We will say public, and it's not stated that it returns anything. So it's void. We say public static void, and it's called swap. And it takes as input 2 points, point P1, comma, point P2. And then what you would actually do is to swap the x and the y coordinates, not to swap P1 and P2, and this is the difference. It didn't state to swap P1 and P2. It stated that swap the values of x and the y. Okay, if you remember from CSEN102, if I have two integers and I want to swap them, I need most probably a temporary variable to store one of these values, and then I can do the swapping. We will apply the same here. However, we need to have two variables. Why is that? Because you have both x and y coordinates. So we have a temporary variable for the x and temporary variable for the y. And both are of type double. Why double? Because the x and y variables here were of type double. So here we will say something like double temp x, and you can put anything of them. I can say, for example, p1.x, and I will do the same for the y. I will say double temp y is equal to p1.y. Now I've stored the p coordinates in the temporary variables. What I would like to do is, I would like to swap p1.x with p2.x. So I will say p1.x is equal to p2.x, and p1.y is equal to p2.y. Okay? Okay? And then now you have the p2 in the p1, but p2 so far is as is p2. No, I would like to get the values of p1 in p2, which are so far stored in the temp x and temp y. So what I will add is, I will say p2.x is equal to temp x, and p2.y is equal to temp y. And that's it. Okay? This is for the static swap. Continue. The other method is swap, and it takes as input only one parameter, and it says that it swaps the values of x and y coordinates with that of the point object on which the method is invoked, which means that this swap method is an instance method. So it takes as input one point, and where is the other point? We will invoke the method on. Okay? So let's implement this. I will say public. I will not say static because it's instance. And then the return type is also void. And then it's called swap, and it takes as input only one point p. And we'll do the same for this, the temporary thing. However, not for p1 and p2, however, it's for this and for p. So we'll write it once again. We'll have something like temp x is equal to, think of this dot x. Is it okay? This dot x means what? This dot x means store the x coordinates of the object on which the method will be invoked. And we can also remove this keyword from this line, however you can keep it. So we'll say double temp x is equal to this, and we have the same for the y. And then you will say that that this dot x is equal to p dot x, which is the input. And you will say this dot y is equal to p dot y. And last but not least, we'll say p dot x is equal to temp x, and p dot y is equal to temp y. And that's it. Okay? We continue to the last method, and it says that you want to do the toString method and override the implementation of the toString method to display the values of the x and y coordinates of the input. So here we say public. We've done this before. Public. The toString method has the fixed syntax, which is, first of all, it's an instance method, so you don't write static. And it returns a string, and it's called toString, too small, S capital, and the remaining is small. Doesn't take any input. And then it says to print or display the values of x and y coordinates. So we can have something like this, return, and then I can write a message, x is, and then plus x, and then plus y is, and then plus y. Okay? So far for the methods that you're asked to implement, and then You're asked to, first of all, let's do number E, which is to augment our class with the main method to test our implementation, and then we continue to number D. So we would like to have our main method. So we say public, static, void, main, and then we say string, args, and then let's start creating some point objects that we can use to implement or call our methods. So I can say point P1 is equal to new point, and then I can give it, for example, 2 and 3. And let's have another one, another point, which is called point P2, and I can give it, for example, 6, 7. Okay, which means that 2 is the, here means 2 is the x coordinates, 3 is the y, here 6 is the x coordinates, and here 7 is the y coordinates. And then, first of all, we can try to print any of these objects. So I can say system dot out dot println, and then I can print P1. So what do you expect to be printed from here? As we said last time, if you say print P1 or an object, or we say print the object dot toString, in both cases, the toString method will be called. And if you have a toString method in your class, then this is the method which will be called. And if you don't have it, then the preference will be printed. Okay? So I can remove this toString because anyways it will be called. And let's compile. Okay, completed, and let's run. So here you say that x is 2.0 and the y is 3.0. We can add here a space so you can see the output. Okay? Okay, good. Let's test something like the add method, which is static. First of all, if you see the definition of the method, it returns a point, which means that when you want to call this method, you should expect a point to be returned from this method, so you need to store it or just print it. You cannot just call the method on its own. So what I can do is I can say point P3 is equal to, and then call the method which is called add, the static one. The static one means that you will not invoke it on any object, so you just call it on its own. So I say add, and then I pass all the parameters as input. So I say add P1, P2. What do you expect to have? I expect to have a point. In the x coordinates, I should have a value 8. And in the y coordinates, I have the value 10. Okay, and this point will be stored in P3. What you can do later is you can print this P3. So I can say system.out.print line P3. Let's compile. And let's run. So here you see the second line, which is x is 8 and y is 10. Okay? Okay, let's test the instance method, which is the add also, to see the difference between the static and instance methods when you call them. If I want to call the instance method, which is the add one, I say, first of all, it's instance, so it needs an object to be invoked on. So I can say P1 dot add, and then I give it the P2. Good. And let's see. Does this method return anything, the instance one? This one? No, it doesn't. It's the void method. So you will call it on its own, and that's it. Okay. However, if you compile, it compiles. And if you run, you will not get any output. It's the same like the ones before. Why is that? Because the addition is done. However, it's done on the P1, and you cannot see it because you didn't print P1 after that. To see the output, you can say system.out.println the P1. So let's compile, and let's run. So here you see that the x is 8 and the y is 10, which is this exact output like this line. However, this comes from a static method and this comes from an instance method. Also, this one is a point P3, which is a new point, and this line, it does not create a new point. It just adds the value of P2 on P1, okay? However, so far we have only 2 points, which are P1 and P2 for this line. However, for this line, you have another third point created, okay? Okay, let's continue with number D, in which you were asked to augment your class with a class variable to keep track of the number of point objects created. What does that mean? Now, how many instance variables do I have in this class? I have 2, which are the x and the y. Now, what if I want to keep track of the number of objects created, which means in the main method so far, by the end of this line, how many points do I have? I have point P1, because you have new point, so you have here 1 point. And then you have point P2, you say new point, so far I have 2 points. And then we print, okay, and then point P3. Is this point P3, is it a new point or is it just a reference? We will see. We need to have a look at the add method, which is the static one. So we go to the add method, which is the static, and then we find that you have a new point something, which means that this method creates a new point. So far, till here, we have 3 points created. 2 I created manually, and the third one is created from the add method. Okay, let's continue. P1.add P2. This add method is the instance method. Let's take a look at the instance method, which is called add. Does this add method create any points? No, it doesn't. It just adds the values of the P on my object. So it does not create anything. So far, I have also 3 points, and then I print, so I have 3 points. However, I would like to have a counter or a variable that stores or that counts the number of points created. Okay, to do this, I need a variable. And this variable, I will write it here. So I can say something like int count. However, if you just keep it like this, it looks like exactly an instance method. Which means what? Which means that any object of type point will be created will have its own count variable, which starts by 0. I don't want this. I want this variable to be shared among all point objects that could be created. To do this, you want to say that this variable should relate to the whole class, not explicitly to only one object. To do that, we'll say something like static. Can I say static for variables? Yes, you can. So we have 2 things. We have static and instance methods, and we have also static and instance variables. We've seen the static and instance methods in these methods. The second instance variables, we'll see it now. These variables are instance variables. These are instance variables. That is an instance variable, and also the y is an instance variable. However, this one is a static variable, which means that this variable is now shared with all objects of type point that could be created. Okay, good. As you remember from CSEN202, if you want to count something, usually we start the counting by 0. So you say static int count is equal to 0. Okay, and now I would like to increment this count variable whenever a new point object is created. So I need to increment it. Where to increment it? Where is the part in the class that creates any point object? The constructors. Okay, how many constructors do you have? I have 2. Then I should write the increment of the count variable in both the parameterless constructor as well as the constructor that takes parameters, because you need to be safe and you need to keep track of any points that could be created. If you call the parameterless or if you call the another constructor. So here I will say plus plus count, and that's it. And also here I will say plus plus count, and that's it. Okay? Now, if I want to print or call this count variable, what you can say is, come in the main method, and I can say something like print, and then this is a static variable, right? So you don't need an object to call, to invoke it on it. So you can just say print count, and that's it. And let's see what happens. Okay, it's completed, and if you run, you get the value 3, which is the number of new points created. As we said, 2 points created from here and 1 point created from this add method. Okay? Also, you can say p1.count, or I can say p2.count. However, you don't need this, but you can also say it. You can also call it, and in both cases, you will get the same value. Okay? Okay so far? So this was our first exercise, and let's go to the other one, which is the triangle. And the reason that we are solving this exercise is it relates to the point class, so that's why we'll solve both exercises. So in this exercise, you are asked to describe a triangle. And it says that a triangle can be described using 3 points that represent the vertices. Okay, let's take a look at our point class. Do you think that when I create a class, I will not use it anymore? Of course not. I create it to use it whenever I want. And even I can use it in other classes. I can just call or create an object in other also classes. So first of all, let's create our file, our class, which is called triangle. And let's have our instance variables. A triangle, any triangle, I can show it to you. Any triangle consists of what? Of 3 points, right? Okay. And you have already implemented the point class. So what you're going to do is use these points in your class to be able to describe a triangle. Now our instance variables are not going to be double x1 and double y1, then double x2, double y2. No, you have points already there from this class. What we're going to do is just I will call these points. So what I will do is I will say point p1. That's it. And then point p2. And then point P3, okay? These are what? These are my instance variables, which are the 3 points that describes the triangle. And then here you see that using the implementation of class point, implement a Java class triangle, which means here I'm going to use the instance variable of type points. And then augment your implementations with 2 constructors. The first is the parameterless constructor that takes no arguments and sets the coordinates of the 3 points to 0, as well as the overloaded constructor that takes 3 points. So let's first do the parameterless constructor. So I will say public triangle because I'm in the class triangle. It takes no parameters, so nothing in the bracket. And then we'd like to think, this point P1, is it created? No, it's not. So does it have any value? No, it doesn't. In the parameterless constructor, you were asked to put values 0 in each point P1, P2, and P3. Okay, however, it's not yet created. So first of all, you need to create it and give it as input parameter 0. So here I will say P1 is equal, create a new point. A point is an object, so you need to say new, and then call the constructor, which is point, and pass the value 0. These zeros are the x and y coordinates, which are the exact input that the point class or the point constructor takes as input. Okay? So here I did that for the P1, and I will do the same for P2 and P3. here I will say P2, and this is P3. And that's it. Okay? Why is that? Because the user did not know any point to create, so I created by default the points at 0, 0. If we removed these lines, the new point something, then the default value of the point will be stored, which is null. Why is that? Because the point is an object, and the default value of an object is null. So I don't want to see null. I want to see something that will not give me an error, so I need to create a point and give it values 0. Okay, that's good. We continue with the constructor that takes parameters. So I will say triangle. And then it takes 3 inputs. Why 3? Because you have 3 instance variables. So here I will say point P1, comma, point P2, comma, point P3. And in the body, all what I'm going to do is just say this dot P1 is equal to P1, and I will repeat, I'm sorry. Okay, let's start once more. This dot P1 is equal to P1, and we'll repeat this line twice for the P2 and for the P3. Okay? So far I have the triangle constructor that takes 3 points and the one that takes no parameters. Let's continue. And then we'll say augment your class with the following methods. First of all, a copy method. And as you can see, it's an instance method because it takes no parameters. And if you're going to continue that, it says that returns a new instance of the triangle object with the same values as the object in which the method is invoked. So that's why it's an instance method. Method is invoked, then it's an instance method. So the definition says that we want to return a new instance of the triangle object. So let's think of it. I will say public, no static because it's instance. And then the return type is what? It says new instance of the triangle object, then the return type is a triangle. And then it's called copy. And it takes no parameters because I will invoke the method on the triangle object that I will create in the main method. And then I can say something like return and then new instance of the triangle. So I need to create a new triangle object. So I say new and then triangle, and then I need to write the inputs. Good. What are the inputs that the triangle constructor accepts? It accepts 3 points, right? So I can here say P1, comma P2, comma P3, or you can say this dot P3, or you can remove it. In both cases, it's accepted. Okay? Good. This is for the copy method. Let's continue. Here you say rotate. That swaps each point with the point next to it. Swaps each point to the point next to it, which means if I have this as P1, this P2, and this is P3, I need P1 to come here, P2 come here, and P3 will come here. To do this, like we did in the point class, when you're going to swap or rotate, you need to have a temporary variable. And in the last class, we needed to have temporary variable of type double. Why is that? Because I was swapping instance variables, which were the x and the y, and they were of type double. However, here, the instance variables are of type point. So I need to have a temporary variable, yes. However, this temporary variable is of type what? It should be of type point because now you are swapping or rotating points. So here I will say public, and it's also instance. And it didn't say that it returns anything, so it's void. And it's called rotate, takes nothing. And now I will have my temporary variable, which is of type point, and I will call it temp, for example. So I will say point temp is equal to, for example, P1, and then P1 is equal to P2, and then P2 is equal to P3, And last but not least, P3 is equal to the temp variable that you stored P1 initially in. Okay? Let's continue. We will have the toString method that returns the 3 points that construct a triangle. And this is somehow tricky, and you need to understand what happens in this method. First of all, I will define the method. So I will say public string toString, and then I will say return, and then, for example, I will say a message point P1 equal, I will say plus, and then I want to print P1, right? Because it's my instance variable. So I will say P1 plus, I will get the same message for each point. I will say point P2 is equal to plus P2, and then plus point P3, and then plus P3. Okay? We will see the output when we call the method in the main method. So let's not do it now. Let's continue for the number D. We say augment your class with the main method that constructs at least 2 triangle objects and tests all methods defined above. And you should also print the number of point objects created. Okay? So let's have our main method. We say public static void main, and then string args. And then let's create our triangle object, the first one. So I will say triangle T1, for example, is equal to new triangle. And let's think of it. I want to create a triangle that takes as input 3 points, which is to call this constructor. Okay, where are these 3 points? Did you create them? Do you have them? No, I don't. And the point is an object, so that it needs to be created to be able to use it. To do this, I need to create 3 points before I call the triangle constructor. So I will say point P1 is equal to new point, and I can give it any values, 1 and 2, for example, and then I will have 3 of that. So I will say point P2, and I will give it, for example, here 3 and 4, and point 3, I will give it 5 and 6. And now, from this, by the end of this line, you have 3 points created. Then now I can be able, and I'm able to pass them to the triangle constructor. So here I will say, create a triangle with the following points, which are point P1, point P2, and point P3. Okay? And let's create another triangle. And I will show you another way to create the triangle and the points in only one line. So I will say triangle T is equal to new triangle. And then you also need 3 points. And most probably you need different points than the P1, P2, P3. So what you can do is, you will say new point, and I can give it, for example, 11, 12. This line means what? This statement means create a point, a new point, and give it the values 11 and 12. And now it will act as the first parameter for the triangle constructor. Okay? It's like abbreviation. Instead of writing the creation in 3 lines, I can write only 1 line. And I will do the same for the rest of the points. So I will say this is point 1, and point 2, for example, would be 13 and 14. And the third one will be 15 and 16. Okay? So here I created 3 points in 1 line, as well as the triangle in also 1 line. And now I'm having 2 triangles, T1 and T2. Okay? Okay. what we can do now is, let's have the copy. I would like to make a copy of triangle T1. To do this, let's first look at the definition of the method. The copy returns what? It returns a triangle. And let's take a look at the body. It returns actually a new triangle. Okay? So what we can do is, I want to make a copy of T1. So I will say T1.copy. However, as we said, this method returns a triangle, so you need to store it somewhere, or you need to print it. So I can say, for example, triangle T3 is equal to T1.copy. And now let's print our triangles. So I can say system.out.println, and then pass T1, and I will have 3 statements, one for T1, one for T2, and one for T3. And let's compile to see what happens. If you compile, okay, it compiles, and if you run, let's take a look at the output. So here it says what? Point P1. Let's take a look at the toString, because this method comes from the toString. However, it's somehow tricky. We say point P1 is equal to, here it is, point P1 is equal to, and then we see something like x is 1.0 and y is 2.0. Yes, the x is 1 and the y is 2. However, here in this line, I didn't write x is nor y is. So can you think of why did this x is printed and why this y is printed? Actually, you will get the answer from looking at this one. Point P1 equal to P1. What is P1? P1 is a point, which is an object. An object should have a class, and here it is its class, which is called point. When you print an object, remember what happens? We call the toString method of this object. Okay, this is the object of type point, so you need to go and look at the toString method, which is in the point class. So here in the toString method, which is in the point class, you see x is something, comma, y is something, which means that this x is comes from where? Comes from the point class in the toString method. From the toString method, which is in the point class. And y is also comes from the toString method, which is in the point class. However, point P1 equal comes from the toString method, which is in the triangle class. Okay? And the same applies for point P2 and point P3. That's why it's tricky, because now it's as if we are calling two string methods. The first one, which is for the triangle, and the second one, which is for the P1. Okay? Okay, good. So let's take a look at the output of our main method. So here we printed T1, T2, T3, and T3 was a copy of T1. So if you look at the first line and the last line, you will see that they are the same because it's a copy of them. And for the second line, it's my new second triangle, which I created. Okay? And now what we can do is we can rotate any triangle. So for example, let's rotate triangle 3. So I will comment this line and this line to see the output. So here I only printed T3 and I want to rotate it. Let's take a look once more on the rotation. The rotation does not return anything. So it's a void method, so we just call it on its own. So I will say, if I want to rotate T3, then you say T3 dot rotate. Okay? And as we've seen before in the point class, you will not see the output unless you print T3 once more. So let's have this line once before the rotation and once after the rotation. And let's see the output. So first of all, the first point was 1 and 2, the second point was 3 and 4, and the third was 5 and 6. Now, after rotation, the first point is 3 and 4 instead of 1 and 2, And the second point is 5 and 6. And the third point is 1 and 0, 1 and 2, which was the first point passed. Okay? So this means that our methods are correctly defined and they are working well. So this was for this session, which concludes the objects and classes topic. And inshallah, we'll continue next time with a new topic, which is called arrays, one-dimensional array. And see you inshallah next time. Goodbye.